Algebra 1, 1-5 equations. So we've spent some time talking about expressions the last few lessons. Now we're going to talk about equations. So here are some examples. An expression does not have an equal sign. It might look like this, 3x plus 7. That's an expression. Notice there is no equal sign there. An equation will have an equal sign. And it might look like something like this, 3x plus 7 equals 13. That's an equation. One side is equal to the other side. That's important to try to get into your brain. It's not just that it has an equal sign, but one side is equal to the other side. This expression is equal to this expression. So as we work through this, and as we're going to see soon, if you do something to one side, now these are no longer equal. You have to do the same thing to the other side. So we will see that soon. Now let's find a solution. A solution is a replacement value for the variable that makes the equation true. So I've got to find the number, the value that I can replace for that variable, and your equation will be true. This is what we try to find when we are asked to solve with an L, an equation. So, for instance, let's look at our original equation up there. 3x plus 7 equals 13. And so what we're going to do here is what we do is what we do to one side, we do to the other side. So I'm going to subtract 7 from both sides to get the x by itself. And so then 7 minus 7 is 0. So I end up with 3x equals 6. 13 minus 7 is 6. I've done the same thing to both sides. Now I still want this x to be by itself. Right now I'm multiplying 3 by it. So that means I've got to divide by 3 from both sides in order to get the x by itself. So that means 3 divided by 3 is 1, so I just have 1x now, equals 6 divided by 3, which is 2. So now I've got x equals 2. Now if I were to plug this 2 back into here, I'd have 3 times 2, which is 6, plus 7 equals 13, and that looks good. So now let's go ahead and do this representation, or this application of this idea that we're just thinking about. Find the solution set for the following equation, for this equation here, if the replacement set is this. So what we're going to do is we're going to take this set, these are the numbers that we need to plug in for Q, and see which one works, or which ones work. So this is how we do it. We say 2Q plus 15 equals 23. That's our original equation. Oh, should be 13. Oh, I think it's supposed to be 23. This is supposed to be 23. Is that what happened? Oh, let me double check here. Let's find. Yeah. Oh, no, it is supposed to be 13. Okay. Sorry. 13 is correct. Okay, I'm looking at my notes from last time and I was a little bit unclear. All right, 13 is correct. Oh, but this is 15 is supposed to be 5. That's what happened last time. Okay, so this is correct. 2q plus 5 equals 13. Okay, so now we are going to use these numbers. We're going to plug them in for q to see which one of these is true. So we're going to plug in the 2. I'm going to say 2 times 2, I'm plugging in that 2 for Q, plus 5 equals 13. And we're going to check to see if that's true or false. But we're going to keep going here. We're going to write out all of these and see which ones might be true and false. 2 times 3, I'm plugging in 3 for Q, plus 5 equals 13. And we could put a little question mark here to see, just to remind yourself, we're going to check this in a minute. 2 times 4 plus 5 equals 13. 2 times 5 plus 5 equals 13. And 2 times 6 plus 5 equals 13. Okay, so let's work each of these out. 2 times 2 is 4. 4 plus 5 is 9, so that's not 13. False. 2 times 3 is 6. 6 plus 5 is 11. 11 is not 13. So these are not equivalent statements. 2 times 4 is 8. 8 plus 5 is 13. This one is true. 2 times 5 is 10. 10 plus 5 is 15. 15 and 13 are not equal. This statement is false. 2 times 6 is 12. 12 plus 5 is 17. 17 and 13 are not equal. This statement is also false. So we just have one solution out of this replacement set. And so we say the solution set looks like this with this weird, I forget what the name of this parenthesis thing is like that, but that's what it is. So this is what you'll see in the homework as to how to talk about what the solution set is. All right, so now let's do a U try. So your replacement set is 0, 1, 2, and 3. And your equation is 8m minus 7 equals 17. So now go ahead and just do what we just did for this mess with this mess. Go ahead and pause, and then we'll look at it together. Go. And let's see how you did. All right, I'm going to take the replacement set, each of these numbers, I'm going to plug them in for m. So 8 times 0 minus 7 equals 17, question mark. 8 times 1 plus 7 equals 17, maybe. 8 times 2 plus 7 equals 17. And 8 times 3 plus 7. Oh, I switched it to plus. What's wrong with me? These should also all be minus 7. Losing my mind. Minus 7 equals 17. All right. Now, let's go ahead and do all of these and see which ones are true or false. 8 times 0 is 0. 0 minus 7 is negative 7. Negative 7 does not equal 17. This is false. 8 times 1 is 8. 8 minus 7 is 1. Does 1 equal 17? No, it does not. 8 times 2 is 16. 16 minus 7 is 9. 9 does not equal 17. This statement is false. 8 times 3 is 24. 24 minus 7 is 17. This one is true. We have a solution set of 3. That's it. That's how it's done when you're doing solution sets and replacement sets. Now we're going to solve equations in a different way, the way we did a little bit right at the beginning of this lesson. So let's fill in some blanks and do a couple examples. Here we go. So I created this little graphic to try to hopefully help you understand what's happening here. So if I have an expression on the left and an expression on the right, I want to keep them equal. So if I add something to one side, then my scale is going to tip. And what I have to do to keep it level is to add the same thing to the other side. So if I put a grape over here, this is going to tilt. I need to put that same size grape over on this side so that it goes back to being equal. All right, so let's keep the balance. What you do to one side, you must also do to the other. The goal is to get the variable by itself on one side of the equal sign. That is what we do so much in algebra. So let's do, we're going to do an example and then a u-try, and then that's going to be the end of this lesson today. It'll be time for you to go do your homework. Here's an example. 6 plus 5 squared minus 5 divided by 2 equals p. This one, we've got p already all by itself. So let's go ahead and do this problem here together. So we need to do parentheses first according to PEMDAS. So we need to do the parentheses. We're going to do the power inside of the parentheses first before we can subtract in here. So so this is the exponent, right? 5 squared is 25. 25. So 6 plus 25 minus 5 divided by 2 equals p. Oh, this is a bad example of what we're trying to do, isn't it? We're going to keep this going here. 25 minus 5 is 20. 6 plus 20 divided by 2 equals p. And now we need to, can we add this 6 and the 20 together? No, we can't. We've got to divide first. 20 divided by 2 is 10. 6 plus 10 equals p. 16 equals p. Now, this example is not an awesome example of what we just did here, and I'm going to change it for next time. I did not make a note for myself like we should have. So, for this u-try here, we're just going to do this one together. 7 minus 4 squared minus 10 plus n equals 10. And then we might do 1 or 2 examples after that. Okay, let's do what's in the parentheses first. 4 times 2, 4 squared, which is 4 times 4, that's 16. Minus 10, 7 minus 16 minus 10 plus n equals 10. 16, now I need to continue with the parentheses. 16 minus 10 is 6. 7 minus 6 plus n equals 10. 7 minus 6 is 1. 1 plus n equals 10. Now I'm going to subtract 1 from this side because I want the n to be by itself. So if I subtract 1 from this side, what I do to one side, I have to do to the other side. 10 minus 1 is 9. N equals 9. Again, remember, when I write a 9 like that, you might write a 9 like this. Either way is fine, except for this way is better. All right. Let's do one more example here that just to keep working with this so you can get one more in here. So let's say 10x minus 5 equals, let's say 25. Yeah, 25. That works. Okay, so in this situation, I want this x to be by itself. So I want this negative 5 to go away. So I'm going to add 5 to this side. And what I do to one side, I must also do to the other side. I'm going to add 5 to this side. So this goes away. Negative 5 and positive 5 is 0. So I'm left with 10x on this side equals 25 plus 5 on this side, 30. I'm going to divide now to get this x by itself. Divide by 10. What I do to one side, I have to do to the other side. 10 divided by 10 is 1. So I've got 1x here. That looks great. 30 divided by 10 is 3. X equals 3. All right. And we will be doing a lot more of these kind of equations as we continue on in Algebra 1 and on the homework and all of that. So that is it for Algebra 1. Is it 1-4 that we just did? 1-5. Woo! Moving along. All right. Good luck on the homework.